The why of significant figures is sort of hard to explain, and it's pretty much irrelevant unless you're dealing with lab work. The idea is it tells us how precisely we know a number to be true. For example, if I tell you I spent $40 on this shirt, you're going to assume I mean around $40. But if I said I spent $40.00, I'm telling you those last two digits because they're exact. So the way we write numbers tells somebody how much we know about the precision of each number or the significance of each number. There are four rules that we use. Any non-zero is significant. Zeros between significant digits are significant. And then we have two rules that apply to decimals, greater than 1 and less than 1. So let's take a look at our first example here, 702,000. The 7 and the 2 are automatically significant according to our first rule. Our second rule says zeros between significant digits are significant. So now I have that one as well. For decimals, irrelevant, this doesn't have a decimal point. So this is going to have 3 Sig Figs. The second example here is written differently for a reason. Do you see the inclusion of the decimal point after? That's telling our reader that we know exactly 702,000. It is telling our reader that all 3 of these digits are also significant. And this number would have 6 significant figures. I assume that this one is rounded to 702,000, where I assume this one is not. Take a look at the next number. Once again, the 7 and the 2 are the significant. According to my second rule, zeros between significant digits are significant. Doesn't matter whether there's 1 of them or a billion of them, they all count. So this number has 4 significant figures. Okay, 12 and the 1 are significant, the 0 between it. How many significant figures does this have? 4 sig figs again. Okay. The first two are like our previous examples with the 702,000. This number only has 1 sig fig, whereas this number has 3 sig figs. 1.0 times 10 to the second is another way of writing 100, but it is telling us that these are the significant digits. When a number is in scientific notation, we look at what comes before the times 10 to the whatever. So though this number also means 100, it's telling us that 2 of the digits are known to be exact. So I would assume if I have a number like this, that it was either rounded up from 95, down from 104, or anything in between. I know this number is really somewhere between 95 and 104. Okay, let's take a look at our next 0.00500. So 5 automatically significant. For this one, what rule would we apply? For decimals less than 1, any digit to the right of a significant digit is significant. Decimal less than 1, anything to the right of the significant figure is significant. So this also has 3. You should be able to think through the next two. Once again, with scientific notation, we're only looking at the part before the times 10 to the. So this one has 3, and this one has 1. What if I gave you something like 120.000? How many significant figures does this number have? Well, the 1 and the 2 are. Then it's a decimal greater than 1. So anything to the right of the decimal point is significant. So these 3 are. Then we can go back and pick up the second rule still. A 0 between significant figures is significant. So this has a total of 6 sig figs. You will always have an unbroken string. They always come in a row of what is significant and what isn't. Now, these rules will be applied in subsequent videos.